Today we are going to learn on the process on how to do programming for CNC machining. This is more part we're going to use. It's called a symbol shaft. It contains operations from threading, turning, grooving, contour turning, and parting off. So you're going to see the importance of using Solidworks CAM vis-a-vis SolidCAM. Many people have ignored the importance of Solidworks CAM, but they have not understood how it's used. So today I'm going to show you a basic way of using Solidworks CAM on programming this part. Basically, I'm using a SolidWorks 2020 version, which comes with an add-on version of the CAM. So if you load your CAM SolidWorks, so this is how the part will look like. This is how the graphic will look like. So I want to load SolidWorks CAM. Basically, it's already here, but if you don't see where it is, actually you come to SolidWorks, the setting, that's an option, then add-ins. Then you go down there where it's written SolidWorks CAM. You see it's already loaded. But if you don't want to see it, you can uncheck here and check here. But we want to see how we can use this SolidWorks CAM 2020 on this SolidWorks and see how it's going to help us program our part. So the first procedure, the first part is actually let's start on the first procedure. Here is where SolidCAM is. Sometimes if you don't see the icons here, for example, if I click on SolidWorks CAM, its setting here doesn't come. You can just point or place the pointer here. You right click, then you go to toolbars. Here is written SolidWorks CAM. You click on it, then it should pop up on here on the menu bars. If it doesn't come, second procedure, you can do the same. You can repeat again so that you actually activate the SolidWorks. And here it is. These are the menu bars for the SolidWorks CAM. So before you program anything on SolidWorks or anything that you need to machine, be it a workpiece, the first procedure is always on the coordinate system. But here we need to select, first of all, select our machine. So you can come here to define your machine. Click define your machine. So we want to define our machine. Because you are using lathe, here this SolidWorks CAM has a 3D milling axis, 4 milling axis, and 5 milling axis. And because you are going to use turn CNC, you're going to use the turn single, then you select it. You select it here so that you can add this CAM. That is the machine. It means now the machine has been activated here. I'm going to use the CNC turning. Then tool grip, it contains all the tools that you need to use. This has been standardized, but if you want to add more tools, you click on add here. So you check on which tool you want. If you're using, for example, maybe you want to check on bow, drill, all of these tools are here. You can select the tool you want, number turn tool, all of them will come here. Then you pick the specific tool you need to use so that use the right tool for turning. All of these tools are here. Actually, because my machine uses the right tools, I'm going to use all of them the right tools. So they are here. You have to add. That's how you do them. First of all, we can do this because already they are there. Let's use the customized ones. Then here you can also go to the post processors. You can select your post processor. For example, if you don't have your post processor, you can download your post processor. You can browse your post processor and even download. You see these whatever have been customized, they are already in the machine. But if you see that you don't know where the post processors are, you you can download your post processors. For this SolidWorks CAM, you should have an extension of .ctl. So let's assume you're using a HAS ST20. The machine is here. Posting, all of them will be checked. Then you click OK. So we have defined our machine. You can come here and now define a coded system where that part origin is the X0, the Y0, and the Z0. But because we're using length, if you have two axes, meaning it's going to use the X and Z axis. The beauty of SolidWorks CAM is that already when you take on the add code system, all of them has been user defined, so you can change the points. Maybe here, this point here. If you want it to come here, if you want to come here, all of them has been placed. So it's up to you to pick. For example, if I want the code system to be here on this point, I can click. You see, it will come. If you want this code system to remain on this part, I just click on this point. There's like a point here. There's like a point here. It should come. Then you see this one has flipped already. It has added you the part. But the easiest way of adding code system is just come here where it's written coordinate system. You click on it, right click, and then you say turn set. Turn set. Already it has placed the code system. You click OK. This one doesn't mean that is this zero, but it actually means that this is where the tool for turning will be coming from. Actually, it's by default. Then you click OK. So that's where our code system is. We want to add our stock. So we can define our stock from this point, or you can define our stock from this point. For example, I can click stock manager. Uh, I want to turn from this point. So this is where my part origin is. This section is where I'll be holding. So I'm going to show you. This transparent one is the stock. The stock is the blank material that you're going to use to cut so that you do subtractive machining to get your part. So basically here it also gives you option to select the material you want. You can check the material here. If you want to see the material, there's some material here, all of them. Like for example, I'm going to use stainless steel 316, steel 316 stainless steel. And then you can go to somewhere here. We want to add our points. So basically it has detected that the stock is 59. That's the major diameter is 9 millimeter. The length, total length is 147. Positive, or total length negative 147. So it is up to you to give the offset. For example, this one on the positive side, I'm going to give a positive a value. Let's say I'm going to do facing. So if the material is extra by 3 millimeter, I'm going to add 3 millimeter. Then it will update that one. Then here where I'm going to clamp, so meaning I can add like 50 mm. So this is the place I'm going to offset to clamp my workpiece. And when you place here, the value also updates here on the base stock. This section, you see it has added because it is where I'm going to clamp to hold. And then this section, there is also affected by 2 millimeter, so where I'm going to do facing. Then there's also offset my stock. I'm assuming my stock is a 75. So 59 minus 75, I can add like, let's say like 10. Let's say like that is a, let's say like 17. I can offset by 17. So this becomes 17, instead of 75, so I can add 16, sorry. Add 16. 16. So, so this is the stock. This is where I'll be holding with the chuck, that is your chuck, and this is where I'll be doing facing. So I can click OK. So already I've defined my stock. If you place your pointer on this stock manager, it will show you. Also I've defined my code system. If you place, for example, let me show um, the isometric part. If I place here, it will show me the coordinate system, the stock, the machine also said that I'm using millimeters, so it's showing me even how I'm going to clamp it. You see, this is the section where I'm going to clamp it. Now, setup has been done. So as a part programmer, you need to know how to put your setup. That's the part origin. This is the part origin where you put, because you're doing turning. For turning, in most cases, the machine uses X and Z. That is a G17 plane, meaning that's the tool will be coming from Z, unless you're doing internal turning. Internal turning, the tool will be coming along Z axis, but external turning, the tool will be coming along the Z and the X axis. So the setup has been done. So next is now you come here. Once you do all this setup, this way you define our machine. Tools are here, the processors, all of them you set here. Then you come to the stock manager, the code systems. Once you finish that, you come to what you call the extract machine number features. This is where the software will detect which features to extract the operation. Like if you are having a contour turning, facing, grooving, threading, parting off. So it will detect all the these features and also add the specific tools for its operation. For example, here, just once you do all the setup, the next procedure is before you do all setup. Actually, remember that for any CNC operator, you need to understand how you're going to clamp this workpiece on the machine. So it's of the basic procedure. Are you want to clamp this side? Are going to clamp this side? How are you going to start? Which operation are you going to start? Then which operation are you going to finish? Are you going to do rough turning, finish turning, or you are going to do only one operation with one tool? But specifically, it's good to use a variety of tools so that you can get the specific or the final finish for your part. So let's assume that all the setup has been done. All our machines, the stock here has been done. Our connect system has been done. Now we can go to what we call extract machine number features. So here, once we click extract machine number features, the software will be extracting all the features that you need to machine that are also already determined on this part. So once it extracts all the features, it's going to place a feature somewhere here on the SolidWorks CAM design feature tree, so that you can see. Yeah, you see, it has detected that we are doing face, rough, and finish. So it has combined face, rough, and finish. It has combined external OD is what you call external turning, rough, and finish, and it's also determine what you call a cutoff. So in case there's a grooving that the tool has not detected, you can now add that operation, but the one has been detected, you can use it to turn. Then the rest you can do now what you call a feature addition or turning addition. This one is now only for external turning. We have used this icon to generate our operations or features. Next is you click this generate the operation plan. So you need to understand which one you're going to start with, like that, and then we finish. So it has rearranged. You see, the first one was it has had combined rough, rough operations and finish operations separately. But this one it has now segregated all these operations to its specific with its specific tools. Now it's also good these operations because you are using face rough, then face finish, rough turn, then turn finish. It's good so that you can rearrange this operation. In only roughing, then we do the finishing. So you can just drag this and then you place, for example, let's go to rough. You can place here. So we start with rough, face rough, then turn rough, then face finish, then turn finish, then last is cut off. And then next is now you can generate our toolpaths. Can generate our toolpaths. Now you see the toolpaths have been generated for this part. Next is we can do a simple simulation to see how this is going to give us an overview. You see how it appears. It is very simple. Very simple. Actually, the beauty of SolidWorks CAM is that it does everything automatically. You see now here is where our clamp is. This is where the three jack is. This is the transparent one is our stock, and this one is the part we are going to machine. This one has only detected features we are going to machine like rough turning, rough facing, but the threading and grooving it has not put, maybe because of the tool is not there in the tool grip. So next episode will add our operations. We'll see how we can do threading and also grooving where the tool has not detected, and operations like maybe if you want to turn this side, you can follow us on the YouTube so that you can learn more how to use this SolidWorks CAM. There's no need of you straining yourself, buying more CAM packages like maybe Mastercard View 360. It's good to use just if you have already bought your license for SolidWorks, you can also, because it comes with SolidWorks CAM inside, the easier for you to use it without adding more expenses on the other CAMs. It's very good for you to use actually. So let's do here all the features to show you how to display. If you want to display to show the differences, here you can show your stock, your section view. The last one here is where I'm interested. In case you are doing internal turning, but you want to show that how the tool is going to cut, maybe the part will be solid, you can click here to change the display if you want it to be wireframe, transparent, or translucent. That is the beauty of SolidWorks CAM. Then here you can increase your speed so that you can see how it can do, or it simulates, or how the machine will be cutting. Now, for example, let's see how this operation will be doing it. You can now start run. This is doing, it has done rough facing. Now it's doing what you call rough turning. Rough turning. You see how it looks like. So if you want more to learn more about this, actually we have a place at industrial area called core maintenance where we are training guys on how to machine parts. Our procedure of teaching people, basically we use the manual way of programming so that somebody can understand the meaning of the G codes. Then once we finish that, we also go to automatic camp, what you call the computer part programming, CPP, where you now use CAM softwares to program so that people can understand how to automate manufacturing. Now it's doing finishing, but remember the finish it is doing, it may not give you the actual finish, maybe because the tool that you have not placed in the tool grip will not have done much work that you want. But if you want to do more tool grip, actually you can use the best tool, what you call a tool called VNMG, that is 35 degree. It will also cut here, it will move all this material so that you can get the actual product. Or you can use a neutral tool if you don't want just to be turning this part and then cutting this. You can use a neutral tool of 35 degrees so that it can cut anywhere that you want. Or you can also customize your grooving tool so that you use a grooving tool as a turning tool to cut where you want. That's how CNC operators normally do their work. So welcome to Dark Green Technologies. It's a place where you can learn more. This was just a simulation, but here we can also do a step through simulation. For example, if I click here, it will tell me how the tools will be approaching. You see, this one is telling me how the tools will be approaching. For example, if I click, it's showing me how the tools are approaching the workpiece and how the tool is going back to the position where the safety positions. or retracting. Normally use the term retracting. And then you can see here these lines are showing you that the tool is cutting. Where it doesn't touch, it means that this tool cannot reach. So you can use another different tool to do finishing. So welcome and enjoy more about machining. Basically, I love using SolidWorks CAM because it is simple to use. It has more features. For example, here it has also stated all operation automatically. But if you want to change the parameters, if you trade the cutting the tool, whatever, you can come here, you edit definitions, and you start now putting features you want that maybe you feel it should match your parameters. You see all of them are here. You can add the feed rate, you can change the material, you can add the spindle speed if you want to use RPM. All the parameters are here. All the features you want is showing you how it's going to cut. For example, if you're doing facing you normally cut along x-axis, that is radial. Then it also has the finishing amount. You can change the finishing amount from, in case you don't want to use a finish tool, you can use it so that you can finish, can do finishing amount. All the fit rates, the static cut amount are here. I'm not going to show you this series, but I will show you next series how you can set all these and customize them to suit your needs. Welcome and be part of this community where we love everything about CNC. It has many features actually. If you are a CNC operator, you will love to use SolidWorks CAM because it's the best ever, and it's very simple to use. Welcome. See you in the coming year, and I wish you happy and prosperous new year.